Welcome back, everybody. So we're in the third set of notes in our trig identities and equations unit here. So today our focus is going to be on solving equations. So we're going to look at a number of examples where we are going to be using techniques that we've used pretty much solving equations in all of our past courses to solve equations involving trig functions. And the only challenge here is going to be now we have to kind of know all of the values where our trig functions are going to be equal to specific values. So what we'll note on the first page here is that these are what we call first degree equations. So if we look at all of these examples on this page, everything is degree 1, meaning it's not squared, it's not cubed, it's not raised to a square root or something like that. So our powers are all 1. And so the only difference is that we don't have a polynomial linear function. We have a linear trig function that we're going to be working with. But the same idea is going to apply to any type of linear equation, which is if I'm trying to figure out what the unknown is, I isolate it by addition, subtraction, multiplication, and division, as well as possibly factoring. So factoring is also going to be something nice. So for 1a, you could solve this on your own. So we could add 1. So we could write 2x is equal to 1, divide by 2, x is equal to half. Super easy, simple linear equation that we solved in 5th and 6th grade. Same idea is going to apply when we're working with a trigonometric equation. So we've got 2 cosine theta minus 1 is equal to 0. So we'll add 1 on both sides. So 2 cosine theta is equal to 1, and then cosine theta is equal to 1/2 by dividing by 2. And obviously, 1/2 is going to be a really nice unit circle measure, right? So if we're thinking back to our unit circle, cosine is going to equal 1/2, right? At 2 specific values, and we're doing 0 to 360 here. So we'll note theta is equal to the inverse cosine of 1/2, but really we're just looking for those coordinates on the unit circle. So drawing a triangle helps, or drawing the unit circle, or doing like inverse work, whichever one works for you, is what you're going to want to use. And what we'll note with our previous inverse work is that our restriction is now set by the problem. So it's not going to be the function restriction, it's just going to be the expression's restriction on the given theta domain. So we should get that arc cosine of 1/2 is either 60 degrees, which is pi over 3 radians, or 5 pi over 3 radians, or 300 degrees. So our two solutions are going to be pi over 3 and 5 pi over 3. All right, so looking at B, this is going to have an analog here. So again, if we were solving this, we would want to isolate our variable. So we want to combine all the x's and isolate the constant term, which is rad 3 in this case. So we could subtract x and subtract rad 3. And so we'll get x equals negative rad 3. And we're done here, but we're going to not be done here. So we'll do the same thing here. We'll subtract the tangent and subtract the rad 3 to the other side. And so what we're going to end up with here is negative rad 3. So again, we can use the unit circle as our reference. So if we're negative radical 3, we're going to be along that line passing through our unit circle. And again, you can draw kind of a slope triangle if you want to. So we know that we've got radical 3, 1, and 2 as our base side lengths here. So we know that theta is going to be a 60-degree reference angle. So theta is going to equal arctan of negative rad 3, which should give us 120 degrees, which is 2 pi over 3 radians, or 4 pi over 3 radians, which is 300 degrees. So again, just using unit circle values here. So all the work we should be doing here should be non-calculator. And again, our given domain is 0 to 2 pi, so 0 to 360, so we don't have to worry about finding more values than those two. So then for our last equations here, same ideas. Oops. Same ideas are going to apply. We might need to distribute a little bit. So for number 3, probably want to write this as 3 cosecant theta minus 3 minus cosecant theta minus 2. Maybe move everything to one side and combine. So we get 2 cosecant theta minus 5 is equal to 0, which means 2 cosecant theta is equal to 5. And so cosecant theta is going to be equal to 5 divided by 2. So now, 5 over 2 is not a simple known value. So for this, we're going to have to approximate. So we're going to have to approximate this with our cosecant of 5 over 2. But what we could also do, because that, we don't have an arc cosecant button here, is we can note that this is the same as solving for sine theta. So this is the same as if sine theta is equal to 2/5. So theta will equal arc sine of 2 over 5. So now we need to find two angle measures for which this works. So let me grab my calculator here. And maybe we'll do this in degrees for this example. So let's see. So arc sine of 2 divided by 5 is going to give us the first quadrant angle. So that's 23.578178848. So we might round to 3 decimal places, 2 decimal places, kind of options between. And again, we're going to want to think unit circle here. So sine is positive in the first quadrant, and it's going to correspondingly be positive in the second quadrant because it's our y value. So to get from this degree measurement that we've started with, we'll subtract from 180. And so we'll end up with our other angle measure being 156.42182115. So our two answers here are going to be a little bit messier. Key idea being you're going to need calculators to solve some of these. And so for number 4, we'll subtract our sine to the other side and subtract 5. And then we'll get sine theta is equal to -5 over 2. So that means that theta is going to equal arc sine of -5 over 2. But -5 over 2 is -2.5. And so we know from the unit circle that sine theta is stuck between -1 and 1. So that means there is no solution. So we can have no solution. So these are all of kind of the linear equation types of examples you're going to see. Some may involve factoring and then solving as linears. So that's what we'll look at next is our quadratic examples. So second degree trig equations. So on the left, 1a, 2a, you might want to solve both of those. So if we look at 1a, we'll look for factoring, but we might need to use the quadratic formula. So in this case, looks like we would have x and x, maybe minus and plus since we have -4. So if we look here, okay, so -4 plus 1 looks like it works. So x would equal -1 or 4. Perfect. For 2, this one is going to involve the most important thing that you do not do right? So what we would do here to solve is we would factor out an x, and then once we have a product, we know that one of these things has to equal 0 by the zero product property. So either that is 0 or that is 0, or they're both 0. So we'll note that x is equal to 0 or 1 would be our solutions. But the one thing you never want to do is divide by x. Don't do that. Because, as you'll notice down here, one of our solutions is 0, which means you're dividing by 0 and you're going to lose a solution. So make sure that you do not divide by 0. So just be very, very careful of that. So let's go ahead and look at our trig versions of these problems. So again, we'll write these out kind of in a factoring form. You could think of these as x squared and x. So sometimes you can do substitution when you think about it. So we'll have tangent theta times tangent theta, and then we're going to have minus 4 and plus 1. So that means that tangent theta equals -1, or tangent of theta is equal to 4. So there's going to be two different sets of values that we end up with here. And for tangent, just note that tangent doesn't have any restrictions. So this is going to have solutions for both. So theta is going to equal arctan -1, and theta is going to equal arctan of 4. Now for -1, that's going to be kind of easier for us. So on our unit circle, that's going to be when our slope is exactly -1, which is halfway into each quadrant, or 45 degrees. So in the second and fourth quadrant, that will be 135 degrees, or 315 degrees. Arctangent of 4, however, we're going to need to use a calculator. So that is going to give us 75 degrees, 75.96375653, or, so note if we have positive slope, right, we're going to be in the first and third quadrant, so I can add 180 to this first answer to get 255.96375653, so the same decimal value, just with 180 added to it. So all of those will be solutions between 0 and 360. And note this will be an approximation. And so for B, we'll again factor out a sine theta, not divide. So then we'll get sine theta is equal to 0, or sine theta is equal to 1, and then solve for each one. So theta is going to be arc sine of 0, or arc sine of 1. So sine is 0 at 0, pi, and 2 pi. And arcsine is equal to 1 at pi over 2 and 3 pi over 2, or 90 and 270. So we're going to have 5 solutions here. So definitely be very careful with those endpoints. So note 0 and 2 pi are going to be equivalent values, but they are different angle measures. So we need to include all of them. All right. And then we've got some additional examples down here. So go ahead and pause the video for a moment and give both of these a try. So looking at number 3 here, I think we're going to want to factor, hopefully. So we should get cosine theta, and let's see, minus 3 plus 2. Looks like it's going to work here. But then we're going to get cosine theta equals -2 or 3. But that's not possible, This cosine is stuck between -1 and 1, so there are no solutions. Number 4, we can multiply both sides by tangent. So what we'll want to be careful with here is we need to assume that tangent theta is not equal to 0, right? So if 1 divided by tangent works, tangent obviously cannot equal 0. So that's going to be an assumption we're going to have to make here. Okay, so now we need to solve this so we can square root both sides. So we get tangent theta is going to equal plus or minus 1. So note when we're square rooting a square, we still need to assume that what we are squaring could be a positive or negative value. So theta is going to equal arctan 1 or arctan -1. And that's going to be all the 45-degree angle measures. So 45 and 225 will be the positive angle measures, and then 135 and 315 will be the negative angle measures. So we're going to have 4 solutions here. All right, so those are the first 2 pages. We're going to jump into some quadratic formula examples next time. So if you do have any questions, shoot me an email, drop by my office hours.